Okay, so I want to start this out with not a prop yet, but more or less, I want to start out with a concept. Okay, so here I have a pizza. See if you actually still recall what I'm doing here. Oh, great. Okay, great. Here's your pizza, right? Okay, I'm gonna go and cut this pizza up into 4 equal slices. Yes.
One vertical line in the middle. One.
Okay. All right. Good. So I have 4 slices at this point, and I ask you to eat 1 slice. And I also ask you, okay, can you tell me what portion of pizza did you just eat?
1/4.
Okay, what? That's easy. 1/4 of it. Fine. So you ate 1/4 of the pizza, right? It involves some kind of fractions. There's some part to it that you ate, and there's the whole pizza, which is made up of 4 slices. That's how you got 1/4. Part over whole. Do you recall that concept from before?
Yeah.
Chapters? I mean, yeah, we covered this here too. Part whole, percentage thing, percent change. And also, you did cover this concept back in 7th grade. Okay? But it goes deeper in this too. We got ourselves a fraction here to represent what we ate. What if I asked you to find what percentage did you just eat?
25%.
How do you get 25%?
Just convert it.
Okay, so how do you convert that fraction to a percentage? Divide. Okay, fine. Let's divide. What goes in? The side. The 1. Okay, so top number goes in the house. Fine. And the 4 goes outside. Okay. I want to address this misconception because a lot of you, or some of you will probably think that, oh yeah, the bigger number will always go inside and the smaller will go outside. That's not true, right? You know that by now. But the top goes in, the bottom goes out. That's how it is. We end it there. Because I still have people thinking that, for example, 2/6 is 3. 2/6 is 3, for example. Because you just want to find the easy way out. Because it's a lot easier to take 6 divided by 2, which is 3, and not the other way around. But you know for a fact that 2 goes in, 6 goes out. Okay, when you divide it, you know you're going to have to get back some kind of decimal. But here we go. 4 goes into 1. How many times?
0.
0 times. So here it is. We borrow ourselves a 0. Don't forget to place that decimal there.
2.
4 goes into 10 2 times. So that's going to give you 8 minus that. We end up with a 2. And then we have another 0 down here. And so we have 5. So it's 0.25 or 25 hundredths, so to say. And that's a decimal system, right?
Yeah.
If we want to convert it back to a percent, we would move
Twice to the right.
and that's how we got the 25%. So we ate 25% of the pizza, which left us 75%. So that's this concept I'm trying to sell you today. That if we're going to deal with some kind of percentage system here, we know it's going to involve some kind of division problem. It's going to go involve fractions too, something about part over whole, for example. That's what it is for this particular problem. Now, if I present you now with the problem, this is our problem. It's involved 2 shapes. Let me just read it to you. Some farmers use an irrigation system that waters a circular regions in the field, so we know it involves a circle. Suppose a square field, so we also know that it involves a square. Suppose a square field with size of length 2x is irrigated from the center of the square. So think of yourself as, so you have yourself a square field and you put your irrigation system right in the center of that field, and it's shooting out water. And it's going to go all the way around, and as it goes all the way around, it will create a path of a circle, right? So everything inside the circle will be covered by that irrigation system. Anything that's not, meaning the shaded part of this, will not be covered. Okay? So my question here, what I'm asking you to find today is, what percent of the field is actually irrigated, meaning covered by the water? Okay? So think about that as a pizza problem as well. This is what I'm asking. How much did you eat, that circle, out of the whole square pizza? So that's the same kind of concept. So for you to find something like that, what do you need to find? Yes? Area. Very good, because you need to find out how much did you eat. I mean, what surface did you cover, right? So what kind of surface do we have here? We have what? What kind of surface?
Square.
We have a square surface and we have a circle surface. So let's find the area of the square first. Do we know anything about the square?
Yeah. It's side times.
Side times. Okay, first of all, let's write this down. We know that the area of a square is side times side, right? Okay, side times side, and do we know anything about the side of the square?
What?
2x. Okay, so that means this is 2x. That means this is also 2x, right? So side times side means 2x times 2x. If 2x times 2x, what is the answer then? 4x squared. Believe it or not, I still have some student thinking that it's 4x. Now we've talked about this extensively. That x times x is not x. 2 times 2 is not 2, right? Therefore, in this case, x times x, how many x's do you see here? 2 of them. How do we write it? Write it as power? It's x squared. So it's going to be 4x squared. This is the area of a square. Do we agree? Do we consider that the square is the whole surface, the whole thing? Okay. And do we consider the circle to be a part of the whole? Right? Because this is inside the square. So when we represent the concept of part versus whole, is it part over whole? Just like how we eat 1 slice of the pizza out of the 4. So 1 out of 4 is part over whole, right?
Yeah.
So when we use that, don't you agree that the area of a circle is over the area of a square?
Yeah.
Part over whole. So when we do that, we still set up the same way. Do you know how to find the area of a circle? Yes, Isaiah. Okay,
Has to do with pi.
of course, it has to do with pi. Very good. Mark, go ahead.
Pi r squared.
Pi r squared. So see it? Every time we're going to do something like that, we got to have our structure now. We've got to set it up. Start with the very basic of, okay, yeah, I know I have to do with some kind of circle here over on kind of some kind of square. Then we go to a little bit more specific. We're talking about formula in this case. So we have pi r squared is our area of a circle, side times side is our area of a square. Now we move on to the next step. What is the radius of this circle? X. It's already given, so I can just now replace that radius with x. So I can write it as pi, not r, but x squared, right? See it? Gotta understand something here that I do not have to give you a number to represent the side now. I can just give you an expression if I have to, a variable if I need to. Doesn't matter. But whatever I give you, you just substitute it in. So what you end up now is pi x squared over 4x squared. Okay, and you say, how am I going to solve for this thing? I never asked you to solve it. I only asked you to go ahead and simplify to the nearest whole percent if possible. In this case, can I simplify something? X squared. Do you agree that we actually did something like this before? This whole thing is considered to be one term because pi times x squared. That multiplication sign is the linking or the glue to make everything into one term. So if you have to expand it, will it look like that?
Yes.
And 4 is simply x times x like that, isn't it?
Yes.
Did we do this before?
Yes.
What do we do with the x then? We cross them out. They cancel. We have 2 x's on top, 2x in the bottom. They automatically cancel. It's like 5 divided by 5. Don't they cancel out as well? X divided by x, cancel. So what we end up with is pi over 4. And because I asked you to go ahead and do it to the nearest whole, I just go ahead and round it. What is pi equal to? 3. Don't have to give me 3.14 because I asked you to round it. So 3. And 3/4 is considered to be what?
75%.
Okay, 0.75, or if we convert it, it's 75%. That means this irrigation system right here cover 75% of the field, which left what? Not water.
No, it's what's it called?
What's not covered? How many percent? If 75% is covered, what's not covered? 25%, meaning the shaded part right here, if you have to add them all together, that accounts for 25% of the field. That's not covered by the irrigation system. You see it? Any question on that first problem? Just kind of give you a jump start to the problem. And you kind of see what's going on here. That it will involve some kinds of cancellations. It will involve fractions for sure. Okay? Because chapter 11, let me just tell you right now, up front, is a blend of chapter 8 and some fraction concepts as well. Fraction, chapter 8, together, chapter 11. So if you know your fraction, you know chapter 8 very well, chapter 11 is just another breeze. Okay, so let's move on to our first example here. And you actually like it too, at least for the first part. Take a look at this one. Did we have something like this before?
Yes.
Yeah.
Way back, right? But yeah, the reason I bring this problem up again is because guess what? It is technically a fraction, isn't it? You have one term on top, one term at the bottom, whereas there is a numerator, there is a denominator. I want you to go ahead and simplify, meaning clean it up, make it smaller. Is there anything that we can actually clean up? Yes.
Take away 2 cubes.
Let's start with the number first. Take care of our numbers. Yes, 64 and 16. What can we take away? We can take away 8. Okay, if you take away 8, meaning you divide each by 8, what do you have left?
8 over 2.
8 over 2. Can we still do something with 8 over 2?
Yes.
Divided by 2. So that means we can have 4 over 1. So we took care of our numbers. Let's move on to our variables. Q. Take a look at Q. Yes, Isaiah.
Take 2 cubes away. I mean 1 cube.
1 Q away, and so how many Qs do you have left?
1.
Where? Bottom. Very good. So you remember this. That, of course, we have 1 Q in the top, 2 Qs in the bottom. We cancel out, of course. We still have 1 Q in the bottom, or we start with the higher one, right? This is 2 Qs, and that's 1 Q. 2 minus 1 is 1. And because we start at the bottom, our answer is going to go in the bottom. Okay? What about the R? And top bottom. Top. Okay, what's the S?
That's crossed out.
S crossed out. Done, and so that is our answer. Done. That's it. That's how we simplify it. And we call this what we call a rational expression. Reasons, it's involved fractions. Remember, rational fractions. So we just simplify rational fractions, rational expressions right here. We start with something easy that you can actually recognize, and I'm going to lead you right into chapter 8. Deja vu all over again, and you will hear me questioning you about ordinance, GCF, 2 terms, 3 terms, 4 terms, dots, PST, Xbox, everything all over again. And hopefully, by using this chapter 11, it's going to serve as a review for you for chapter 8. Okay, so take a look at the next problem here, and this is what we have. I got 4x plus 8 divided by x squared plus 6x plus 8. By the look of this, it is one problem, one gigantic fraction problem. However, if you look closely though, separating the numerator from the denominator, you have yourself 2 of the chapter 8, isn't it? So let's separate them. Do it one problem at a time. So I'm going to go ahead and start with the very top. 4x plus 8. I'm going to ask for ordinance. Is that in order?
Yes.
Is there a GCF?
Yes.
Yes. If there's a GCF, let's go ahead and take care of it. What is the GCF for? 4. If we take out 4, what do we have left
X
inside?
plus 2.
Okay. Simple as that. The power is 1 now, so therefore I know I'm done factoring. Unless I have like power of 2 or whatever that I need to worry about. But in this case, I just took care of the factors above. I do the same thing for the bottom now. Look at the bottom. What's the first question we ask again? Ordinance. It is in order, and I guarantee you most of them are in order, so you can certainly bypass that. GCF, anyone?
No.
No, fine, move on. How many terms do I have?
3.
3, so I do not look at the 2 term or 4, I just look at
PST.
3. Is it PST?
Yes.
Okay,
No.
for those, if you say yes, that means you can look at 8 right here and tell me, is there a number multiplied by itself to give you an 8?
No.
See it?
Xbox.
Okay, Xbox it. So we set up an X right there, and what do we put on top? 8. Bottom? Okay, and this is where people struggle. Cannot find that right pair of numbers that will give you a product of 8 out of the 6. 4 and 2. Okay?
Every time it's odd.
4 times 2 is 8. 4 plus 2 is 6. We got that. And do we need a box for this?
No.
Why?
Because it's a 1 X plus X.
It's a 1. Right. We can certainly bypass that. And so I can just now write it as x plus 4, x plus 2. Right? Okay, so here's something I want to introduce before you start your cancellation process. First of all, I have 4 times x plus 2. At the bottom, I have x plus 4 times x plus 2. Once I have that in a group, they stay together in a group. Do not ever try to cancel anything out separately. As a group, if you want to cancel x plus 2, you better have x plus 2 on top as well. In this case, we do. There's a group of x plus 2 on top. There's a group of x plus 2 on the bottom. We know they are alike. Just like a on top, a on the bottom, we can cancel them out to simplify. But before we do that, I need to introduce you to the concept of excluded values, or in this case, depending on the number of terms I have. Excluded values. What are excluded values? Well, as it turned out, excluded values are the value that would make the denominator goes to 0. And I just mentioned the word zero again. Did we cover something about 0 in chapter 8? What is that called? Z2P, zero product property, right? And why did I focus on the denominator this time? Because we learned from before that if I have, for example, a number divided by 0, what will happen to it when you have a 0 at the bottom? No. It is what? When you have a 0 at the bottom, what will happen? Undefined. No solution. Undefined. And this is what we fear. We cannot have a 0 at the bottom. Ever. Okay? Therefore, I need to look right here and say, wait a minute. I have here x plus 4 and x plus 2. There is some value of x that will make it 0. So I have to find them first before I hit that. Finding 0 means set it to 0 and solve for it, just like we did in chapter 8. Solving for the 0 using 0 product property. So let's take x plus 4 and x plus 2 to solve for 0. X plus 4 equal to 0, that's one case. And x plus 2 equal to 0, that's another case. Shockingly enough, people tend to forget how to solve for this x. How do you solve for x? Subtract 4, right? Yeah, that's what I thought. Okay, subtract the 4, x is negative 4. Fine, what about the other one?
X is negative 2.
Minus 2, so x is negative 2. So what I have right here, 4 negative 2, are called excluded values. Reason? Because if I take a negative 4, plug it back into here. Negative 4 plus 4? A 0. 0 times anything is a 0. And because I have a 0 in the bottom, I know I have an undefined answer, and I don't want that. That's why I have to, basically, I have to warn people first that, hey, whatever you pick for x, do not pick negative 4 or negative 2, because these are my excluded values. Don't use them, ever. Okay? Anything else will work, right? But negative 4 and negative 2 would not work. Please do not pick them. That's why you need to identify them before you do anything else to it, okay? So notice what I just did. I take what I have, I factor, then I find the 0 at the bottom, meaning using 0 product property. Now I'm done with the excluded value. I go back to the same problem again. I say, can I now simplify? And you notice that I have x plus 2 on top. That's a group, and I do have the same exact group in the bottom. And you know what's happening? We have the same thing on top and bottom, right? What do? We cancel. And there you have it. What do we have left? 4 over x plus 4. And this is our simplified form. And that's it, we're done. So we identified excluded values, and we simplified. Done. That's it. So if you notice that it takes 3 steps here. We factor, we find the zeros, and then we simplify.
What did you do there to get to that?
I just cross out like terms.
Why?
I do have like terms. Because I have like terms, I can cancel them. Just like the previous problem, right? We have like terms, so I cancel to make it smaller, simpler. Okay, that's all we're doing to this kind of problem. Yes, Mark?
Did you have to find the value of x?
You do. If I ask you to find the excluded value. If I ever ask you to find the excluded value, after you factor, you have to find the 0 in the bottom. Once you're done finding the zeros, you can still go ahead and cross out like terms. Okay? Your simplifying step should be the last step. Okay? After you're done factoring, find the excluded value, then you can use simplify. Alright, take a look at this next problem right here. It makes more sense too. Take a look at this. So, once again, what we have here is 2 problems in one. It's the same kind of deal again. We have 3m squared plus 9m plus 6 over 4m squared plus 12m plus 8. Okay, so let's start one problem at a time. Let's take a look at the top. What can we do with the top? GCF, I know. So you already bypassed your order. That's because they are both in order, so I can just move on. Is there a GCF on top? You say, yes. What can I take out?
3.
3. If I take out 3, what do you have left inside?
M squared plus 3 plus 2.
Okay, and the bottom. 4.
I can take out 4 and I have m squared plus what? 3m plus 2.
Ooh, look at this. I have the exact thing on top and bottom I know, so that means I just have to do what one time? Can't cancel yet. We have to find our excluded value, so that's why we have to break it, factor it first. So how do we factor out m squared plus 3m plus 2? What do we ask ourselves? Yes. So is it a PSD? No? Okay, so we just do x on it. And what do we have? Cannot cancel yet until we have our excluded value, right?
2 on top, 3 on the bottom.
2, 3 on the bottom. What times 1 will give you 2 add 2 to 3?
1, 2.
1 and 2. Okay, and do we need a box for this thing?
No.
No. So we certainly bypass it and just expand it.
Here's the 3, not m, not x with m. M plus 2, m plus 1. Okay, then we also have 4, m plus 2, m plus 1, right? Because the bottom looks exactly like the top. Do we, okay, of course, at this stage you can find your excluded value, meaning you set the bottom to 0. Can you tell me what are your excluded values? M cannot be -2 and m cannot be -1. You can just go and write it like that on the side. What it cannot be. M cannot be -2, m cannot be a -1 because if I do have such a case, the bottom will turn to 0 and I won't have any answer. Therefore, I want to avoid it as much as I can. Okay? Alright. Now, do we see anything in common that we can actually cancel out? What? M plus 2. Please do not ever do something like this. Oh yeah, that's m and m cancel. No. As a group, not individual. Because when you put that inside of parentheses, they go together. Cannot be separated. So m plus 2, that's together. M plus 1, that's together. And what you have left is 3/4. And that's your answer. Done.
Yeah.
That's all we're doing. What question do you have?
Nothing.
Hey. Are these easy enough, I hope?
Man, calm down.
Okay.
Alright, let's see what we have after this. Oh, yeah, I guess you will have quiz after all.
Okay.
Oh.